So welcome back. In the last video, we were talking about area of regular polygons, and we said that this one formula will work for any regular polygon. So any regular polygon that you have, this formula is going to work. So let's take a look at a few more examples whenever you're missing a piece that you need. So if I take a look at this picture right here, I know that I have a triangle, and to find the area of any regular polygon, I can use that formula from before. Area equals 1/2 little a capital P. Remember that the little a stood for apothem. Now, in this one, I have the perimeter. If one side of this triangle is 6, that means that it would be all the way around. So the perimeter would be 18. What I don't have is the apothem. I don't have that little height right there. But I know the perimeter is 18 because that would be 6 all the way around. So I could just do 6, add them all up, or I can just do 6 times 3 because it's all the way around. What I'm missing in this one is I'm missing the apothem. Okay, now like hexagons had that special rule where the radius and the side were the same in a hexagon. Triangles also have that rule, and that's that to find the apothem, I can do the side divided by 2 divided by root 3. And that's not a rule that you need to memorize. For now, just know that if I do that, the apothem is going to end up being root 3. So if I know that the apothem is root 3, and I'll walk you through that process later, essentially, this ends up being 60 degrees. This ends up being 30 degrees. So you end up with a 30, 60, 90. So what you end up doing is essentially you do 6 divided by 2 and then divided by root 3 anyways. And I end up with this getting root 3 right here. Now I can find the area of this triangle. So with a half earlier, I don't want a half a root 3, but I can half 18. Half of 18 would be 9. Tack on the root 3, so the area would be 9 root 3 units squared. So where you have to be careful in these problems is if you're missing something. Like on this one, we were missing the apothem. I did tell you that, so then you're good to go. Once you have the side and the apothem, you're good to go. So let's take a look at this one right here. And I have a problem with this one, and the problem with this one is that I have the radius. I don't have the apothem. Remember, the apothem is the little height. And I don't have the side either. Okay, now if you remember, this is a 6-sided shape, so that would make this a hexagon. And hexagons, like triangles, have these little shortcuts. They have these rules. So in a hexagon, if the radius is 8, if you go back and you look at the previous example, remember, in a hexagon, whatever the radius is, that's what all of your sides are. So if the radius is 8, then all the sides would be 8, which would make the perimeter 8 all the way around would be 8 times 6. That would be 48. What I'm missing is the apothem. Remember that for area, I have to do 1/2 little a capital P. So I need that apothem in there. And if I go back, hexagons like triangles have a pattern. And like I said earlier, you don't have to memorize this pattern. I'm going to help you out with this. But if I look at this pattern, 20, 20, 20, half of 20 would be 10 root 3. Hexagons and triangles, because they have 3 sides and 6 sides, you end up with all these 30, 60, 90s within, and you get this pattern. So if I have 20, 20, 20, half of 20 would be 10, tack on a root 3. So on this one, if all the sides are 8, figure out what's half of 8, and then tack on a root 3, and that will be your apothem. So what's half of 8? 4. Tack on a root 3. There's your apothem for root 3. Like I said, you don't have to memorize that. That's a rule that I'll help you out with. Just know hexagons and triangles have some shortcuts because they're 3-sided and 6-sided shapes. So back over here, I know the perimeter. Found that. I found the apothem. So I'm going to do half. The apothem was 4 root 3 times the perimeter, which is 48. Remember that half of 4 is just 2. So then you can just do 2 times 48, and then we'll tack on the root 3. So 2 times 48 would make that 96 root 3 units squared, because area is always units squared. Now, these problems would have been much easier if we had the apothem in the side already. Like if you go back, this one didn't take very long because I had the apothem and I had a side. The square didn't take long because I had the apothem and I had a side. But on this one, I had the apothem and I had the radius. Remember, the radius is what goes to the vertex of the shape. So I had to use that information to do Pythagorean theorem, and then I can figure out the perimeter. So if we take a look at this one, I'm in the same bind. I have the radius, I have one side. What's missing is the apothem. What's missing is the little height. So if I were going to do area equals 1/2 little a capital P, remember that P stands for perimeter. So if one side is 20, all the sides are 20 all the way around. So if I go all the way around, 20 all the way around, that would make the perimeter. 20 times 5 is just 100. The problem that I have is I don't know what the apothem is. But if you see it, I have a right triangle. And you can remember Pythagorean theorem will always tell you that. So if I resketch this out, I know the hypotenuse is 17. I know the base of that right triangle would just be this half, which isn't 20. That half would be 10. There's your x. Remember, whenever you're looking for a leg that you're going to subtract, so it'd be 17 squared minus 10 squared. And I put that big square root on top because that would be your last step. So if you do 17 squared minus 10 squared, you end up with 189, but then you need to square root 189. And that just goes back to Pythagorean theorem. And the square root of that would be 13.75. So I do know the apothem now. The apothem right there, I just found it from Pythagorean theorem, would be 13.75. So area would equal 1/2. The apothem I just found was 13.75. And the perimeter we said earlier, if one side's 20, they're all 20. So the perimeter would be 100. And then from there, if you need to go to the calculator, just go to the calculator and type that in. And then remember, you can divide by 2 at the end. So the area would be 687.5 units squared, because area is always units squared. And we were missing the apothem, and that's why we had to do Pythagorean theorem. So taking a look at this next one, I'm also missing something on this one. I have the apothem, that's 2.5, the little height. I have the radius is 2.7. That's like the hypotenuse always will be the radius. That's 2.7 because it would be the same all the way around. What's missing on this one is I don't know what this side is. I don't know what that is. So if I were going to do area equals 1/2 little a capital P, area equals 1/2, the apothem is 2.5. What I don't have is the perimeter. So I'm going to have to do Pythagorean theorem again. Anytime you're missing your apothem or you're missing a side, Pythagorean theorem is going to get you there. So if I draw that triangle, my radius is my hypotenuse at 2.7. My height is 2.5, and I'm looking for this leg. So remember, whenever you're looking for a leg, you're going to subtract. So you're going to do 2.7 squared, the hypotenuse squared, minus 2.5 squared. And then you're going to square root that. Don't forget to square root at the end. You get 1.04, and then you square root that, and you end up with 1.02. It's like 1.019, which would round to 1.02. Now, where you have to be careful on this problem is if I go back and I look at this triangle, 1.02 is this piece right here. The full side isn't 1.02. 1.02 is this piece right here. The full side would be 1.02 and 1.02, which would make this full side, the full side would be 1.02 and 1.02 would be 2.04. And once you have that, then you can use that to get to the perimeter. If you count all your sides, so 1, 2, 3, 4, 5, 6, 7, 8, 9, this is a nonagon. So 2.04 times 9 would make the perimeter 18.36. And then from there, you can just go to the calculator and type it in. And you get that the area is 22.95 units squared. Now, where these problems get tricky is whenever you have to do Pythagorean theorem to find the apothem or the side. But if you have the apothem and the side, then all you have to do, like these first ones we did, all you have to do is just plug it into this formula. Best of luck on your practice. If you take a close look at it, I did tell you which problems require Pythagorean theorem, so I tried to help you out there. Good luck.